So it's going to be a curve. As I'll show, we can have fractional exponents. They're curves also. But in order to graph this now, we need a third point and probably more. So if we pick x equals 2, now 2 cubed is 2 times 2 times 2. It's x 3 times itself. X times x times x. So for 2, it's 2 times 2 times 2, which is 2 times 2 is 4, times 2 is 8. This is when you hear an equation is growing exponentially. Exponentially now means that these aren't one-to-one correspondences anymore, because we've gone over 2 units for x, and already on y, we're at number 8. So curve. Now we'll choose a value to determine what's happening on this side of the x-axis. So let's choose, say, -2. Well, now, since it's an odd number power, before negatives times a negative made a positive, but now a third times a negative is going to bring it negative again. So -2 is written -2 times -2 times -2. -2 times -2 is positive 4 times -2 is a -8. How would we graph that? -2 for the x, -8 for the y. So on your own you can choose other values here and see that you can plot them on this line that we'll see goes off this way. All cubed functions have this curve to them. Commit this equation to memory. And this is the last for the algebraics. Although I will mention the fractional exponent. Because if we have x equals y squared, something in mathematics that we can do is take the square root of both sides. Well, if we do that, the square root of x is still the square root of x. And this could equal the y. Now, in order to graph this, what we see is that the square root of x can actually be written as x to the 1/2 power. In order to graph this now, this exponent, it's not 1, so it's not a one-to-one correspondence again. It's going to be a curve. We'll make our xy table and pick some values. 0 again is the easiest. Square root of 0 is 0. Square root of 1 is still 1. So if x equals 1, y equals 1. But now, let's pick a number we know the square of, 4. 4 is the square of 2, so the square root of 4 is what we're doing here. If x equals 4, y equals the square root of 4, which is going to be 2. So we go 1, 2, 3, 4 units for x, only increases to 2 for y. If x equals 9, square root of 9 we know is 3. And this is where it comes in again that we can have plus and minuses, because the square root of 4 can also be plus or minus 2. So this would be both plus and minus. So what we see is now we get a curve going this way for positive values. If x is 4, now y would be minus 2, so we're down here. X is 1. If x is 9, minus 3. This graph's that way. All positive values for x in the square root. Density. 3 variables in this equation. And the density is simply the mass divided by the volume. These units may seem new to you at this point. They're really quite simple. Written D equals m for mass over v for volume. Now, one of the beginning problems in chemistry will be, if you know the density and you know the mass, what is the volume? First step, always, unequivocally, is deal with the symbols. Don't go plugging the values in for these yet. A question will read the density of something is, and you have a mass of it, what is the volume? So you're given these values. These equations you'll usually be given to, so all you need to do is rearrange it to put it in a form where what you're looking for equals that. So say we want to know what the volume of something is. The power of the equal sign, and this is where the parentheses for multiplication come in extremely handy. We want to multiply both sides of the equation by volume. The reason we want to do this is because we want the volume equal to what we're looking for. So what we see here, use the parenthesis and then a bracket. The mass over the volume times volume is going to be the volume canceling. It's going to result in the mass. And what the mass equals is the volume times the density. But we don't want to know the volume times the density. We want to know explicitly the volume. So what we do now is we divide both sides by the density. In order to do that, it's 1 over the density. It's the same as dividing if we multiply it by that. Parenthesis times parenthesis, put a bracket around it, that's a multiplication. Do the same thing to this side, because of the equal sign. We have 1 over density times volume times the density. Now the densities will cancel, leaving just the volume. What the volume equals now is the mass times 1 over the density, which is mass over density. And now all we would need to do is plug in the given values from what the question might be. A mass, which will be in grams. And the density, which will be given in grams per milliliter. Now what these units turn out to be is what we're analyzing. This is called dimensional analysis. Sounds technical, we're analyzing the dimensions. Mass is simply grams, always, sometimes kilograms, but still a gram is the root. Density in grams per milliliter. What this is, we can invert this and multiply it in order to get a fraction out from underneath here. What we'll see is the grams cancel, and this is the same as 1 over milliliter. This can be inverted and multiplied times 1 will equal milliliter. That's the unit we want for volume. So we know that it's right. If we somehow got the density up here, that volume equal mass times density, the units would not come out correctly. So this is dimensional analysis. It sounds technical, but it's something we know. A volume is going to be in milliliters. a mass is going to be in grams.